The North American P-51 Mustang had been forced to land intact after a navigation error over occupied France. German technicians had spent weeks repairing it to make it airworthy. Now it was Lurz's turn to fly the aircraft. What he discovered in the next hour would confirm Germany's greatest fears about the air war. The Americans had built a fighter that was simply superior, and there was nothing Germany could do to stop it. Lurcher squeezed into the cockpit. The first thing he noticed was the visibility. The bubble canopy provided an unobstructed view in nearly every direction. In contrast, German fighters still used frame canopies that created blind spots. He could see his own tail, and checking 6 o'clock was easy without straining. In a dogfight, visibility meant life or death. The engine roared to life. The Packard-built Merlin V1657 engine produced 1,490 horsepower at war emergency power. The German Me-109 G6 produced 1,475 horsepower, which seemed roughly equal on paper. However, Lurz was about to learn that horsepower alone didn't tell the whole story. He pushed the throttle forward. The Mustang accelerated smoothly down the runway. There was no taut pull, no tendency to swing. German fighters required constant rudder corrections during takeoff due to engine torque. Lurch noticed this immediately. In combat, every moment of distraction mattered. The aircraft lifted off. Lurz retracted the landing gear and felt the acceleration. The Mustang climbed at 3,475 feet per minute at sea level. The Bf-109 G6 could only manage 3,346 feet per minute. Close, but still not quite the same. However, the real difference appeared at higher altitudes. At 20,000 feet, the Mustang's two-stage, two-speed supercharger maintained its power, while the German single-stage superchargers lost efficiency. At 25,000 feet, the Mustang could reach 437 miles per hour, while the 109 could only achieve 386 miles per hour at the same altitude. But the American fighter was still climbing and accelerating. Lurz pushed the Mustang into a dive, then pulled up sharply. The controls remained light and responsive. The hydraulically boosted ailerons gave the P-51 an exceptional roll rate at high speeds. In contrast, the Bf-109's controls became stiff above 400 miles per hour. Pilots had to use both hands to turn at combat speeds, but Lurz turned the Mustang with just his fingertips. He performed a series of aerobatic maneuvers, loops, rolls, split S-turns. The aircraft responded instantly to every input. No lag, no mushiness, no surprises. German test pilots had reported similar findings with other captured Allied aircraft, but Lurz understood what these characteristics meant in actual combat. He dropped to a lower altitude and opened the throttle fully. The Mustang accelerated smoothly past 400 miles per hour, faster than any German fighter could reach at comparable altitudes. The laminar flow wing, which reduced drag, gave the P-51 a top speed advantage of 20 to 30 miles per hour over its German counterparts. In combat, this difference meant American pilots could choose when to engage and when to disengage. Then Lurz checked the fuel gauges. This was where the comparison became devastating. The Mustang carried 269 gallons of internal fuel and could hold two 108-gallon drop tanks, giving it a total capacity of 485 gallons. The Bf-109 G6, on the other hand, carried just 106 gallons internally, and with a single drop tank, its total capacity reached only 185 gallons. The implications were staggering. The P-51 could fly from England to Berlin and back with fuel to spare. Spare fuel for combat over the target was one of the key advantages of the Mustang. While German fighters had to scramble from bases close to their targets, fight defensively, and return to base before running out of fuel, American pilots could escort bombers across all of Germany, stay with them for the entire mission, and engage German fighters whenever necessary. After completing his evaluation flight, Lurz landed and immediately filed his report. The findings were clear, decisive, and devastating for Germany. The P-51 was superior in nearly every measurable aspect. General Adolf Göhlen received the test pilot reports. As the general of fighters, responsible for all Luftwaffe fighter operations, Göhlen had been in this position since November 1941. At 29, he had already achieved 104 confirmed aerial victories and commanded fighter wings during the Battle of Britain. He understood air combat better than most. The reports from Rechlin confirmed what Göhlen already knew. Germany was losing the air war. Golan didn't start the war as a general. He began as a lieutenant, determined to prove himself. During the Spanish Civil War, Golan flew ground attack missions in the P-51 biplane, but he shot down nothing. He bombed Republican positions, strafed trenches, and completed 300 combat sorties without any aerial victories. When World War II started in September 1939, Golan commanded a ground attack squadron, flying Henschel HS-123 biplanes over Poland, but still no aerial combat. Despite this, he repeatedly requested a transfer to fighters, but his requests were denied. The Luftwaffe needed experienced ground attack pilots. Finally, in May 1940, Golan received his transfer. He was assigned to WW2 27, flying the Messerschmitt Bf 109E3. He was 28, older than most fighter pilots, with hundreds of combat sorties but still a novice in air-to-air combat. On June 12, 1940, Golan shot down his first aircraft, a Belgian Hawker Hurricane, over Liesge. 7 weeks later, he had 17 confirmed kills. By the end of the Battle of Britain, Golan commanded WW2 26 with 57 victories. His rise had been meteoric. Golan's success was due to his exceptional situational awareness. He could track multiple aircraft at once, predict their movements, and position himself to gain an advantage. His pilots observed that Golan seemed to know where every aircraft would be before it arrived. He credited this ability to experience and constant vigilance. In November 1941, Golan became General der Jagdflieger, the general of fighters. At 29, he was responsible for all Luftwaffe fighter operations, including training, tactics, equipment, and strategy. Despite his administrative role, he continued flying combat missions, adding 47 more victories to his tally. By the end of the war, Golan had 104 confirmed kills. By June 1944, when Lers tested the captured Mustang, Golan was facing an impossible situation. The Luftwaffe was losing the air war, not because of a lack of courage or poor tactics, but because of simple mathematics. In January 1944, the Luftwaffe had around 1,500 single-engine fighters on the Western Front. The United States Eighth Air Force alone had 1,580 fighters, while the Royal Air Force added another 2,500. The combined Allied fighter strength exceeded 4,000 aircraft, more than double the German force. The production numbers were even more dire. In 1943, Germany produced approximately 11,000 single-engine fighters, while the United States produced around 24,000, with Britain adding another 11,000. Combined Allied production was roughly double that of Germany's. The Allies' combined production of 35,000 fighters was more than 3 times Germany's output, and the quality gap only deepened the disparity in numbers. Golan understood that his pilots were facing increasingly superior equipment. The Focke-Wulf FW-190, which had been excellent when introduced in 1941 and still competitive in 1943, was now being outpaced by the rapid advancements of American and British fighters. The P-51 Mustang, in particular, represented a massive leap in fighter technology. The P-51's development was almost accidental. In April 1940, the British Purchasing Commission approached North American Aviation with a request to build Curtiss P-40 fighters under license. James Kindleberger, the president of North American, proposed an alternative. His engineers could design a superior fighter in the same amount of time. The British were skeptical, as designing a new fighter typically took 3 to 4 years. However, Kindleberger promised a prototype in 120 days, and the British, in desperate need of aircraft, agreed. Edgar Schmood, North American's chief designer, began work immediately. He had studied various fighter designs, including British, American, German, and French models. Schmood identified the key weaknesses of existing fighters: excessive drag, poor high-altitude performance, and insufficient range. His solution combined several innovative features, including a laminar flow wing that reduced drag by 20%, a sleek fuselage with minimal frontal area, internal ducting to cool the engine efficiently while minimizing drag, and a large internal fuel capacity that provided unprecedented range. The prototype was completed on September 9, 1940, and its first flight occurred on October 26, 149 days after the contract was signed. The aircraft was fast and handled beautifully, but its Allison V-1710 engine performed poorly above 15,000 feet. The RAF tested the Mustang and deemed it unsuitable for combat over Europe, relegating it to ground attack missions. In April 1942, a Rolls-Royce test pilot, Ronnie Harker, flew the Mustang. On April 30th, at RAF Duxford, he immediately recognized the aircraft potential, but only the engine was inadequate. Harker suggested installing a Rolls-Royce Merlin engine, the same power plant used in the Spitfire. North American received 5 Merlin engines in July 1942, with Packard Motor Company in the U.S. starting licensed production. The engineers installed a Packard Merlin V1653 in the 5th prototype, and the modified aircraft first flew on October 13, 1942. The results were dramatic. The top speed increased from 390 miles per hour to 437 miles per hour, and the service ceiling rose from 31,350 feet to 41,900 feet. The Merlin's 2-stage supercharger maintained power at high altitudes, making the P-51B Mustang the fastest fighter in operational service. But it wasn't just speed that made the Mustang revolutionary, it was the range. All fighters in 1943 faced the same limitation. Engines consume fuel in proportion to their power output, meaning more power resulted in shorter range. Fighter designers had accepted this as an unchangeable law. The P-51 broke that law. Its clean design reduced drag, meaning less power was needed to maintain speed, resulting in lower fuel consumption. The P-51B consumed 85 gallons of fuel at cruise power, whereas the P-47 Thunderbolt consumed 205 gallons. The Mustang's incredible range allowed it to fly further than any other fighter of its time. The P-51B was capable of flying over 2,000 miles with drop tanks, while the P-47 could only cover 85 miles on 205 gallons of fuel. The Mustang could fly from England to Berlin, 580 miles one way, escort bombers there and back, and still have hundreds of miles of range remaining. This left enough fuel for nearly 2 hours of combat over the target. The first P-51BS arrived in England in November 1943. Their initial deployment was cautious. The 354 Fighter Group received the first planes and began escort missions in December. The results far exceeded expectations. On December 13, 1943, P-51s escorted B-17 bombers deep into Germany on a mission to Kiel, covering nearly 1,000 miles round trip. No bomber escorts had previously reached targets that deep into Germany. German fighters, accustomed to attacking bombers after their escorts had turned back, found themselves facing American fighters over the target. The Luftwaffe lost 18 aircraft, while the 354 Fighter Group lost none. By January 1944, Mustang groups were flying even deeper into Germany, forcing the Luftwaffe to change its tactics. German fighters now had to engage the escorts rather than the bombers. Combat shifted from bomber interception to fighter versus fighter battles, where the P-51 performance advantages proved decisive. The Luftwaffe losses increased dramatically. In January 1944 alone, the Luftwaffe lost over 1,000 aircraft on all fronts, more than half of them fighters. German factories struggled to replace the losses, with production barely exceeding attrition. February 1944 was even worse. The 8th Air Force launched Big Week, 6 days of maximum effort strikes against German aircraft factories. From February 20th to February 25th, American bombers flew 3,800 sorties, with P-51s escorting them throughout. The Luftwaffe fought desperately to defend the factories, committing every available fighter. In the end, they lost 355 fighters in just 6 days, about 18% of the entire German fighter force. Pilot casualties were catastrophic, with 100 dead, 60 missing, and 40 wounded, resulting in the loss of 200 fighter pilots in less than a week. This was a situation when German test pilots flew the captured Mustang at Rechlin. The reports confirmed what Golan had already understood. Germany was facing not just a superior aircraft, but a weapon system that undermined German defensive strategy. Golan had been in a long-standing battle with Rear Marshal Hermann Göring over aircraft strategy. Göring, who commanded the Luftwaffe and controlled all aircraft production, reported directly to Hitler, but his decisions were increasingly at odds with military logic. In November 1943, Golan had requested that all fighter production focus on air defense. Germany needed fighters to defend against Allied bombers. Nothing else mattered. Göring refused and insisted that bomber production continue, arguing that Germany still needed bombers to strike England, even though their range was diminishing and their losses were unsustainable. Göring also requested modifications to the Me-262 jet fighter. Its speed made it an excellent interceptor, capable of reaching bomber altitude quickly, launching slashing attacks, and escaping before escorts could respond. However, Hitler insisted that the Me-262 be equipped as a fighter bomber, which added weight, reduced its performance, and delayed its production. By the time the Me-262 entered service, it was too late and in too few numbers to make a significant difference. Germany couldn't copy the P-51, even if its leadership had wanted to. The technical challenges were immense. The laminar flow wing, which reduced drag, required advanced manufacturing techniques, and replicating such a design was beyond Germany's capabilities at that time. Precise manufacturing. Surface irregularities of more than 0.01 inches disrupted the laminar flow. German factories, increasingly damaged by Allied bombings, couldn't maintain those tight tolerances. Another obstacle was the Packard Merlin engine. Reverse engineering it would take at least 2 years, something Germany couldn't afford. Installing a German engine like the DB603 would require redesigning the entire forward fuselage. The DB603 was heavier than the Merlin, which would shift the aircraft's center of gravity and necessitate extensive structural modifications. Materials also posed a significant problem. The P-51 used aluminum alloys optimized for high-speed flight, but by 1944, Germany was facing severe shortages of aluminum. Many existing German aircraft had already switched to substitute materials, with steel components replacing aluminum where possible. This increased weight and reduced performance. But the fundamental issue was time. Developing a Mustang copy would take at least 18 to 24 months from design to operational deployment. Germany didn't have that time. By mid-1945, the war would likely be over. The Luftwaffe pilot training program was collapsing. In 1940, German pilots received 240 hours of training before entering combat. By 1944, that number had dropped to 112 hours. In comparison, American pilots received 400 hours of training, and British pilots received 340 hours. Fuel shortages only worsened the situation, further reducing training time. New pilots arrived at combat units with minimal flying experience, many having never even fired their guns in flight or practiced aerial combat. They were lost quickly. Between January and May 1944, the Luftwaffe lost over 2,000 fighter pilots, killed, missing, or seriously wounded. Training schools were graduating roughly the same number of new pilots, but they were far less experienced. Meanwhile, American and British pilot quality was improving. Veteran pilots returned for second tours, passing on their experience to new pilots. Squadron commanders in the Allies had 200 to 300 combat missions under their belts, while German commanders had only 100 to 150 missions, if they survived that long. The arithmetic of aerial combat was working against Germany. In early 1944, German fighters shot down 2.5 Allied aircraft for every German loss. While this was a favorable exchange ratio, Allied production could replace losses immediately, but German production couldn't. By April 1944, the ratio had reversed. Allied fighters shot down 2.0 German aircraft for every Allied loss. The Luftwaffe was bleeding to death. Veteran pilots were dying, and the replacement pilots were dying even faster. The institutional knowledge that made the Luftwaffe effective was evaporating. Göring understood this clearly. The reports from Rechlin had confirmed his worst fears. Germany couldn't win the air war or even achieve a stalemate. The best they could hope for was delaying the inevitable. In June 1944, the Allies invaded Normandy. The Luftwaffe flew 319 sorties on D-Day, while Allied air forces flew 14,674 sorties, a ratio of 46-1. German forces fought without air cover, reconnaissance, or supply drops, while Allied aircraft controlled the skies completely. Throughout the summer and fall of 1944, Göring continued advocating for changes. Concentrate all fighters on home defense, stop wasting resources on bomber production, and accelerate the deployment of the Me-262 as an interceptor. His recommendations were ignored. In January 1945, Göring relieved Göring of command, with the official reason being The official reason Golan was relieved of command was a disagreement over strategy. However, the real reason was that Golan had been right about everything, and Göring couldn't tolerate being proven wrong. Golan then requested to return to combat flying, and permission was granted. On February 25, 1945, he formed Jagdverband 44, JV-44, an elite unit flying the Me-262 jets. Many of Germany's top aces, pilots with 100, 150, or even 200 victories, volunteered for the unit. They flew the jets as Golan had always intended, primarily as interceptors. In the next 2 months, JV-44 destroyed about 50 Allied aircraft and lost 4 pilots, an impressive ratio but ultimately irrelevant. Allied bombers flew in formations of 1,000 aircraft, while JV-44 had only 30 operational jets. The numbers didn't add up. Golan survived the war and surrendered to American forces in May 1945. He was interrogated extensively about Luftwaffe operations, and American intelligence officers asked about German evaluations of Allied aircraft. Golan was candid in his assessment. The P-51 Mustang, he said, was the best fighter of the war, combining speed, range, handling, and firepower like no other aircraft. The Germans had captured a P-51, studied it thoroughly, and understood exactly what it represented, but they were unable to respond effectively. After the war, Golan consulted for various aviation companies, including North American Aviation, the manufacturer of the P-51. He advised them on fighter design, drawing on his experiences fighting against their products. The irony was not lost on him. Decades later, Golan remained consistent in his opinion of the Mustang. It had been a decisive weapon in the air war over Europe, not because of any single characteristic, but because of the combination of features. The Mustang could escort bombers anywhere, fight effectively once there, and return home safely. The numbers support his assessment. Between December 1943 and May 1945, P-51 units in Europe shot down approximately 5,000 German aircraft, more than any other Allied fighter type. P-51 losses totaled about 2,500 aircraft, giving it a kill ratio of 2 to 1. But the Mustang's strategic impact exceeded these tactical results. Its range forced Germany to defend everything, spreading their fighter forces across Germany instead of concentrating them against specific targets. This diluted the German defensive effectiveness, making bomber raids more survivable and increasing the pressure on German industry. By early 1945, German aircraft production had collapsed, not due to a lack of factories, but because of a shortage of trained pilots. Thousands of aircraft sat on airfields, unused and unmanned, because there were no pilots left to fly them. The captured P-51 that test pilots flew at Rechlin sat there until April 1945. When Soviet forces approached, German technicians destroyed it to prevent it from being captured intact again. However, by then, destroying one Mustang meant little. The United States had produced 15,856 P-51s by the end of the war. They flew from bases in England, Italy, and China, escorting bombers over Germany, Romania, and Japan. The P-51 evaluated by the German pilots was just one example of a weapon system that had changed aerial warfare. Adolf Golan passed away on February 9, 1996, 1 month shy of his 84th birthday. He outlived most of his contemporaries, both friends and enemies. In his final interviews, he still remembered the reports from Rechlin and the moment he realized that Germany had already lost. The test pilots had confirmed what he had suspected, that Silver American fighter represented everything Germany couldn't match, not due to a lack of engineering skill or courage, but because of the inevitable mathematics of industrial war. The Americans had built a fighter that could go anywhere, fight anyone, and win, and they had built 15,856 of them. That was a number Germany could never match, a capability Germany could never replicate, and a war Germany could never win.